So I'm gonna record this. We're gonna do the best fit line. We're probably gonna do two people's work. Okay, and what we seemed to find in the other class was the slope was mostly when we looked at most people's work was about 4.1 or in the general neighborhood. So actually, let's start with somebody that got close to that and look at their work, and then start with somebody else's and look at their work that maybe wasn't as close. What do you have, Kat? You did. Okay, so she had closer to. So this is kind of an approximate. So Kat's was closer to 4.2. What points did you use? Let's start with that. Okay, so she used 53. Let's see if that makes sense. 125. So 53, 125. Yeah, that's actually pretty good, right? Right on a point. So you want to pick. Notice her point was not one of the ones that was actually a data point, but it is right on the best fit line. So 53, 125. And tell me your other one. 47. Another good point right there. 100. And the numbers are easy to work with. Okay. So your slope then would be rise over run. So subtract 125 and 100 and divide that by the difference of 53 and 47. So that gives you 25 over 6. Okay, and so that's 4 and 5, 6, right? Oh, sorry, 4.1. I was 4 and 1, 6, and that's about 4.16 repeating. So we're going to go with her slope of 4.2 for starters. Does that make sense? Okay. So then you would take your slope, whatever that is, should be close, and put it into the y equals mx plus b form. All right, so what should you do next, Libby? Okay, so you have to use one of the points that she's used, and you have to find b. So pick a point. 100. So is that the y value or the x value? So you're going to place that in place of y. So on this side, what are you going to do? Well, if you use the 100, you've got to use the x part. So what did she do, Katie?
4.2 times 47.
Yeah, in place of x, you're going to put the x part, right? And then you're going to work this out, right? So you guys have calculators there? This is, say that again?
197.4.
Yeah, sorry, I was just thinking in my head before I wrote that down. Okay. So now subtract 197 from both sides. 0.4, I'm sorry. And you get, what do you get?
Negative 97.4.
Negative 97.4, correct. And over here you have b, right? Here. I want you to think about that. When you look at this picture, is it reasonable? Remember, down here, the way your book does these graphs, that is not the origin. Okay, so what you really want to think about is negative 97 reasonable intercept? So if I took a snapshot of this picture, which I had done earlier, and put it on an axis, and I'm going to look at that axis, that on the right is this graph blown up. So if I blow it up a little bit more so you can see this, if it is true that this is 30 right here, and this is 60 right here, oops, that's a 6, that whole length is 30 units. So if this is 30, 0 must be way over here. You see that? And then if this was 20, like it says right here, and you could see the increments are about that big, then the graph really belongs there. So it's a snapshot of the graph. If I took that line and continued it down, which is a little harder to do, and let's go zoom out a little bit, I should hit with this line down at negative 97, or close, right? It's a model, so it might not be exact. So if I take and I start my line here and trace over it and stay on it, is it reasonable? Is her answer reasonable?
Yeah.
Okay, let's think, because, you know, this is like 10, 20, 30, 40, 50, 60, 70, 80, 90. Not bad, right? So the intercept, the mistake that people make, the trap that they fall into when the book does a problem like this, is they automatically just think the intercept is 30. The intercept is not 30. Because this is the coordinate point right here. This is almost the point 20, 30. It looks more like 20, 29 if you look really close. Okay? So it looks like she did a good job there. So her equation is y equals 4.2 x minus 97.4. All right? So now let's look at Rami's numbers, which are different. So we're either going to find that he made a mistake, or that there is more than one, and there are different answers that are both pretty good. Right? That can happen. So we're going to take all of this and get rid of it and look at what he did. So what points did you use? 58, 137. So that would be right here.
38.
That's your mistake right there, Rami. Because that's above 145. So 58. Yeah, if you were looking, you were trying to use this point. Is that what you're trying to use? So let's correct your work now. It's 56. About 137. At that point, Catherine? Question?
No, well, I was looking at for,
Well, let's see what his second point was. What was your second point?
38, 60.
38, 63. Yeah, that looks good. So I can look at it in a minute, Catherine, if you want me to. So for the slope here, now we have 137, take away 63, over 56, take away 38. So 137 take away 63 is 74. And that's 18. So do 74 divided by 18.
42.
What'd you get?
40.
Yeah, so now we're back to 4.1. Is there another decimal place there?
4.118.
1, 2, 1 repeating. Okay, so 4.1 is what we're going to go with. So then we go through that same process, y equals 4.1x plus b. So now what would you do, Libby? 63. Yeah, so you're going to put 63 in for y. Right. Makes more sense now? Okay, do that multiplication for me, you guys. What do we get?
4.1 times 38 is 155.8.
155.8. Somebody want to check her work?
It's 155.8.
Okay, Maggie, subtract 63 minus 155.8 for me.
Could you just do 155.8 minus 63 and then do
Yes,
minus 3?
you can. But yes, absolutely, and I'm just subtracting, showing my work here. So this cancels, and what do you get, Maggie?
Negative 92.8.
Okay, so pretty reasonable still, right? It was a pretty similar answer when we're looking at the two. Y equals 4.1 x minus 92.8. So looking at both pages, they're not the same. They're off, you know, a little bit. They're off by roughly, you know, 4 something. But in the big scheme of things, when we're talking about values that go all the way from 150 down to basically negative 100, 4 units is not very significant. Right? So those are both pretty good answers. So expect something like that on the quiz, on the test. Okay, I'm going to just do a quick run through. Catherine. We can. I'm going to pause this. What happens if I record too much? It's not going to record. So let me pause it and we'll just check it. So it gives like less things for this. The question is, can you choose any point on the line? You want to choose points that lie on the black line, the best fit line. Okay? Now, you want to try to get the points that either are exactly on the line, and you can read them pretty easy, because that's exactly, it looks pretty much on the 38 line, and it's pretty much looks like it's 63. You know, it's a pretty good one, but I have to say that the ones Kat picked were also really good. Like, she picked this point here, or something like that point, which is halfway between 52 and 54. So 53, and when you read over, it's 125. So my yellow point, for example, is not a data point, but it's a good one to use because it's on the black line. And so once you put the black line in, you're sort of ignoring all the purple points unless they're on the line. You're making an equation for the line you drew, not for all those other points.
Nice. In a situation like Catherine's, how many points would you have taken off?
Probably a half point, and then it could be like a 6, 7, 8 point problem, and I would have followed her work all the way through. So not much. Okay. And if my picture's not great, right? If it was a picture where you couldn't tell, I wouldn't have taken anything off. I would have just gone through, I would have looked at her work, and I would have said, oh, those are actually pretty good points, and it gives a little bit more of an error than the one I used. Okay? So talking about the test now, the list of things that I want you guys to study. So I'm going to write it down. Obviously, that warm-up. Okay, so study making a best fit line. Equations. I'm going to give you the line this time. Because you've already been tested on placing the line. That's just an arrow. I'll give you the line. Okay. On the white packet, you should really pay attention to problem number 2. Not because it's more important than anything else, but it does a lot. So we just did the best fit line, but on the white packet, number 2, it goes through inverse relationships, inverse equations, which we haven't talked about in a few days, right? And those are the equations where you might have two variables that always multiply to give you a constant number, like 200, for example, is I think the one from the packet. Except for I think it's like fuel efficiency times gas is always 200.
Yeah.
And then you should be able to plot a graph off of that. You should be able to draw a graph and then plot in the points that make sense, you know, and you should end up getting some kind of inverse relationship. You should be able to write the equation for it. Okay, so that's in the packet. And if you follow that problem 2 all the way through, there's more to it. There's also the second part. It goes all the way through part F, I think. Why don't you guys take a look at that, and I'll pause this for a minute so you can find it. Okay, so in that packet, when you look at problem 2, it has you do a data table. You make an inverse relationship, which is this. You have to answer some questions about it. And if you turn the page, when you get to parts E and F, it's a new situation related to the trip. Now it's talking about gasoline costs, right? It's telling you in E and F that the cost of gasoline is $4.05 per gallon, okay? This graph on parts A through D, this is a graph of gallons versus fuel economy, like miles per gallon. Okay, if you look at E and F, it's different. It's a new situation using some of the same parts of the problem. So when you look at that, it just says, you know, all of these people in the problem are going to figure out how much they have to spend on gasoline. And everybody buys gasoline, you know, in the same area, so it's about $4.05 a gallon. That's a different picture altogether. Because then you just have some kind of, you know, situation. But is it inverse? Like if you don't buy gas, you don't pay, right? If you buy 10 gallons, how much do you pay? $40.50, right? If you buy 20 gallons, you pay
$81.
Right. Is that an inverse relationship? No, right? What kind of relationship is it, Nick?
Linear.
It's just a linear relationship. It's the easiest linear relationship you've learned this year. It goes all the way back to the beginning of lines. So, Catherine, what's the equation for that?
Y equals 4.05x.
Good job, Catherine. Cost equals 4.05 times distance or miles, right? It would be okay to do y and x. If I had given you variables, then that would be it, right? Then you might have some graphing and figuring about that, just like you did on your yellow quiz.
When you do that.
For every mile you drive, oh, I did write that wrong, didn't I? Thank you.
The cost times gallons.
Yes, yeah, I made a mistake. Thank you. I said 10 gallons when I was talking to you guys, but I wrote it wrong. So you're correct, thanks. So there's a problem. What I like about that problem is you have to do some reading, you have to take out data, you have to think about, you know, inverse relationships and linear relationships. So it's a good problem, and we've done it, and you've had a chance to look at the answers. A similar problem, to just add on to the list here, would be in the book. If you wanted one to study, basically if you look at the investigation problem in 3.2 or 3.3, this is about the zoo. And this one is just kind of like the white packet. But if you look at the one, either one of those are good study problems. So 3.3, that problem, it's called planning a field trip, but it's like the zoo field trip. That's on page 66. It's the same thing. You guys might remember it. It was where the science teachers knew that they needed $750 to do this trip, and so the more people that come, the less price per person. And so it's an inverse relationship at first. And then there's a second part that is kind of a linear relationship. So my message is to you guys, you should expect a problem that has a little bit of both inverse and linear. So you would have a best fit equation problem, something like that. Then you'd have something kind of more embedded in a word problem that has a little bit of both. And then the third thing that you should be expecting from section 4.1 to 4.3, what was that about? What we've been doing the last couple days. Correlation was the new thing, right? The correlation coefficient. So things that you would have there are basically be responsible for matching. An example of that would be in section 4. If you look at page 88, you want to find that? So this is an example of knowing what an appropriate correlation coefficient is given choices. You don't have the math background to figure out coefficients, but you have enough background to match them to pictures. Okay? And I think if you study that right there, that pretty much sums up the whole book up through section 4 in, a couple of problems. Is there any questions for me? Yeah, Libby.
So there were the options and 4.3 for the matching, and it was like, so you're supposed to do negative one.
Right.
One of them was like, it wasn't positive, so it was negative, so it would
A 0. That would be like a 0. So I don't know if you guys could all hear her question, but just real briefly, if you had some graphs and you were given choices, and you had to match, so, well, actually, they're not going to give a line at all, but if you had something that was clearly linear and looked very clustered, but not exactly on a line, that would be high. Since it's positive, it might be like maybe high like a 0.9. You might have something that's pretty linear, but definitely not clustered quite like that. That would be a positive correlation, but maybe it's more like a 0.4 or a 0.5. Meaning that it's linear-ish, but you're not really tightly knit around that line. If it's just kind of this kind of thing, yeah, you're going to see closer to a 0 or a 0. If any of those were reversals, right? If this was like that, it would just, the difference in that would be, it's still tight, but it's negative. Isaiah.
So kind of having to do with that too, there was questions in the homework that said, like, it was like, is it closer to 0.5 or 1 or something?
Right, that's this.
Mm-hmm. But it was a different one for like the graph. And, like, what if it, like, if it was like 0.7 or something?
Well, I'm not going to say is this closer to a 0.7 or a 0.8. That's not the goal of the lesson. The lesson is, can you tell if there's a linear correlation or not? So it doesn't look like this. If it's like this, you would hopefully know it's pretty high. So if I said, is this closer to 1, -1, or 0, you would say -1. Okay, if I asked you about this one and I said, is it closer to 1 or 0.5, well, it's not real tight, probably a 0.5. But really, probably what I would do is give you a matching, so it would be process of elimination. That's what I'm looking at. I'm gonna stop this, just because I don't want it to be, not be able to record, and I'll keep answering. Let's see.